Sunshine, lollipops, and rainbows. Everything that's wonderful is what I feel when we're together. Brighter than a lucky penny when you're near. The rain goes, disappears, dear, and I feel so fine just to know that you are mine. My life is sunshine, lollipops, and...
Good morning, fellow early birds. Today you're cooking with Miss Photosynthesis. I'm your host, Sunny. Now, we're gonna have a special recipe today. It's one of my mother's recipes. Ooh, God bless her soul. Now, we're gonna be cooking glucose. All right, I know what you're thinking. What's glucose? Well, let me tell you, it's the most important source of energy in our planet. Now, before I get ahead of myself, let's jump right in. First up, we got a delicious favorite, good old pure H2O. It's light, it's healthy, and it's got a lot of electrons we need. Secondly, we need some carbon dioxide, and guess what? You can find this in your local vacuum, and for a cheap price too. Lastly, but certainly not least, we need some sunlight. Who doesn't love a little bit of sunshine in their life? Let's dive right in. My mama's recipe is a simple one. Easy enough so you at home can follow along. First thing we need to do is put the water into oxygen. This is extremely simple. All you need to do is absorb a photon of light. When we absorb a photon, chlorophyll molecules get excited and the energy splits the water into oxygen gas and a hydrogen ion. The electron release from water excites electrons and sends them cascading down the photostems in the chloroplast membrane, pumping protons in the thylakoid lumen and out through the ATP synthase, creating ATP from ADP. All in all, after our first step, we have ATP and NADPH, an electron carrier. We're already halfway. Next step in this recipe is known as the Calvin cycle. In this step, we're going to take one carbon dioxide molecule and attach it to a 5-carbon RUBP molecule, making a 6-carbon molecule known as Rubisco. The 6-carbon molecule breaks into 3 PGA, and ATP, along with the NADPH, is used to reduce the 3 PGA into G3P, a 3-carbon sugar. Some G3P goes to make glucose, while the rest goes to set reactions, becoming RUBP again. And the cycle repeats over and over. And just like that, we're done. With 2 easy steps, we can make our own glucose and oxygen gas. This recipe is so simple, you can try this at home. Alright folks, that's all we got on Cooking with Miss Photosynthesis. Have a lovely day.
Something better than photosynthesis, man. We got something that makes 3 times as much energy as photosynthesis, man. Come here, I'll show you how it works. Look at you sitting in your seats right now. You're not using photosynthesis, man. You're using cellular respiration. Come here, I'll show you how cellular respiration works over here, man. This stuff's crazy.
Check it. This is a 3-step process. First, we've got glycolysis. We're going to take 1 glucose molecule from food and break it down into 2 molecules of pyruvic acid.
Here, I'm coming in.
Now out of this process, we get 2 ATPs for every glucose. Pyruvic acid is moved on over into the mitochondria, where it's going to be converted to a molecule called acetocoenzyme A.
Now we've got the Krebs cycle. This is going to occur in the mitochondrial matrix. That's the liquidy part of the mitochondria, man. Once these acetyl CoA react with the oxygen gas, All the hydrogens are stripped off to extract the electrons for making ATP until there aren't any hydrogens left, and all we've got is CO2 and H2O. We don't need these, so we're just gonna throw them right out.
Does that work?
This process here only makes about 4 ATP, but we've got a lot of NADH. We're gonna go ahead and use these in our next step here, man.
Now our final step is the electron transport chain, which occurs in the cristae of the mitochondria, these kind of folded membranes. Electrons from hydrogen are carried by NADH, pumping out hydrogen ions into the inner membrane space. These hydrogen ions come rushing in through ATP synthase, and just like that, we make about 32 ATP for every molecule of glucose.
Now, boys, I think you're missing a really big opportunity here. What I make can really help you.
What are you talking about, man? We don't need to work together. We have enough sugar and oxygen on our own, man. It's always been that way.
Yeah, no man, but she makes the glucose, you know? Why not just get it from her? It'd be so much easier.
We've always worked this way, man. We're not a bunch of grass on the ground and trees in the forest. We're cellular respiration, not photosynthesis.
Nah, man, listen up. The glucose she makes will help us easily start the glycolysis process.
Yes, boys, it's much easier this way. It's only best that we work together.
Alright, so let's say we do work with Miss Photosynthesis. How's this all gonna work out?
Alright, I got it, man. Do you want to explain, or should I?
I'll explain. Now I understand this is a bold transition from what you're used to, but it's quite simple. It's the best thing since sliced bread. Now, my byproducts of glucose and oxygen are what you need, correct? Now I'll supply you with my products if you give me some of your CO2 and water. It's quite fair, don't you think?
You know what, if it makes my life easier, I think I can get down with this idea.
Ocean man, take me by the hand.